بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we start a new lecture about recursion. So this is a little bit different topic about object-oriented programming that we have done all along the course. This is the last chapter. It's about recursion. And it's basically the things that you've been doing in 101, but in a different programming style. Okay, in 101, for example, you have done for loops and while loops. And this is what we call iterative approaches, because you do multiple iterations. You do certain task or certain instruction multiple times in an iterative manner. So you repeat this iteratively, and this is what we call an iterative approach. Another approach to execute an instruction multiple times is what we call recursion. So it's a different mindset in programming, okay, which can be more elegant and in some cases has better performance for some particular type of problems in programming. So let's get started. So as you can see, like in this figure, it's like recursion is like a mirror. Okay, so it's like the same task is mirrored multiple times, but at some point in time it has to stop. الآلة لو فضلت تخلي a mirror inside another one, you will find it will go infinity. Okay, one after the other, infinite times. So it's like this, but in recursion we will have a stopping condition or a stopping case where it's going to end at some point in time. For example, at the third time or fourth time or maybe 100th time, depends on how this will be implemented. So now, from programming perspective, a recursion is nothing but a method that calls itself. Okay, a method that calls itself. And usually when a method calls itself, it's like you have a mirror inside the mirror. It's going to run indefinitely until it consumes all the memory and will make stack overflow. Okay, I think you've tried some of the times. We can try to do that afterwards. Okay, so in recursion, we're going to use a method that calls itself, and we will take a problem and we will try to break this problem into sub-problems, which usually need to find what is the stopping condition and what is the case that will be repeating every time. That's basically how we're gonna solve it. So just for you to know the principles now, these are the principles we're going to apply in two examples in this lecture. Okay, every recursive function will have a base case. So when I say a base case later on, it means a case where this is the stopping condition, the case where the recursion is going to stop and roll back from the beginning. Okay, this is like the stopping condition here. This is what we call the base case. And the recursive case is the case that is going to repeat multiple times. Okay, so here, for example, I have 1, 2, 3 recursive case and one like base case, which is the stopping condition. So this is just for you to have an analogy in your mind on what a recursion is. So let me give you this example. Imagine that you have a box and you will unfold these boxes until finding a key. So now if I tell you make a program, okay, in the way that you know in CS101, for example, to unfold until you find a key, how are you going to do it? Maybe you will do an iterative approach, okay, using like a for loop. You have a pile of boxes, nested one box inside the other, okay, and you will try to find the key in this box. So you will do, for example, a while loop. You don't know when you're going to end. Maybe you need to open 10 boxes or 3 boxes. So we use while loop when we don't know the number of iterations, right? Yes. Okay, so we use the while loop. And also in recursion, usually, in some cases, we don't know the number of iterations. So while the pile isn't empty, we take a box. If you find a box inside the box, then add it to the pile of boxes and go back to the pile. Okay, you will do that until if you find the key, you're done. So the stopping condition here is finding the key in the box. You can find it from the first box, second box, multiple box. We don't know how many boxes we need to unfold. Okay, here it's like using a while loop. Is it clear? Yes. Now, how can we do that differently in programming? Is using a recursive approach. Look, it's simpler. It has less amount of code. Okay, we will say go through every item in the box. If you find the box, go back. If you find the key, you're done. There is no while loop. So you're going always to call the same method. Depending on the condition, you're going to call the same method. And one condition is going to take you out. That's the base case. That's the recursive case. So the recursive case is, I find the box. The base case, I find the key. Okay? These two algorithms, they do the same thing. But this is a little bit more elegant in these kind of situations. There are situations where recursion will have more elegant approach for programming. Okay? In some cases also we call it dynamic programming or recursion. Is it clear, the example?
Yes.
Okay. So we're going to apply it to the ever simplest hello world example for recursion, which is the countdown. Imagine now you want to have a program that will count down from 5 down to 0. So now I'm talking about problem solving. Okay, this is very important. Never jump into the code when you do recursion. Never ever. If you jump into the code, you're going to make it wrong. First of all, we need to analyze the problem from maybe mathematical perspective, from logical perspective. We need to find a pattern. We need to find a solution. Are there some students who took computational thinking or start to take the computational thinking? Yes. One of the first things you're going to learn, you need to find a pattern. Okay? Pattern on how to solve this problem. And this is what we are going to do now. Now, to count down from 5, then, okay, if it's not 0, I'm going to count down more. So imagine that you have a function countdown, and every time you're going to call the function until you reach 0. So this is where we're going to stop. This is our base case. You need to have a base case. If you don't have a base case, it's going to run indefinitely, and you will be stack overflow. The memory will be overused. Okay, now if we want to do it as iterative execution, okay, an iterative algorithm will be, you have an input n, which is our starting point, for example 5, okay, and the output will be a countdown from n to 1, okay, and in every step I'm going to send a message indicating the end of the countdown. So I start, I set the number n, for example, equal to 5. Okay, you will do while the number is greater than 0. Okay, print the current number, decrement the current number by 1. And once the number is 0, print countdown has finished. So this is the algorithm. Okay, this is a very simple algorithm. Okay, now we solve the problem. Okay, we can write this as a pseudocode. So this is an example of pseudocode here. It's like you write in plain English. Okay, look. Algorithm, iterative countdown, input, an integer number, n, representing the starting point. The output, a countdown from n to 1. So we start, we set current number to n. This is plain English, but when you read it, anyone can read it, even if someone doesn't know programming. Okay, this is very important. This is problem solving and algorithm design. We need to design the algorithm. We need to design the solution, and then we go into programming. Is the very last step in this kind of problems. Programming is the very last step. Okay, and while the current number is greater than 0, print the current number. You can write system.out.println or print in Python or cout in C++. You can translate this in any programming language. But this is a universal solution to the problem. Okay? And decrement the number by 1. You can do n minus minus or n equal to n minus 1 or whatever language you want to translate it. And once the current number is 0, print, countdown finished. Okay? It's clear, right? Now, I can do that in Java. I will write a main class, a main function, and the class here, and public static void countdown, while number greater than 0, system.out.println number, which is this here, number minus minus, decrement the number, and finally print the countdown is done. Okay, this is the way on how we do problem solving. So this is the iterative approach. Now, if we want to make it, so this is the iterative approach. Now, if you want to make it in recursion, we're going to think differently. So we will have a function. Let's follow the function called countdown. And we're going to define a function that is called countdown. And 5 is different from 0. So I'm going to call countdown again. Countdown of 4. Okay, and then we'll repeat this process. Okay, until we call countdown 0. If I call countdown 0, then it will stop. So 0. So when I come to 0, I print yes, we print countdown has finished. So now doing the pseudocode, or that's the algorithm. Okay, I will do the, just a moment. This is iterative approach. Look now, void countdown int number. So the base case, first of all, when you start with recursion, you need to identify the base case. The base case, what is the stopping condition? The base case, if n equal to 0, I'm going to leave, exit. Else, I will print the number. I will call countdown again. So look, I'm calling the same function. But here, this is the recursive case. You need to make sure that the recursive case will go towards the base case. But how much the base case is something that will be never reached. You have to make sure and know the recursive case will lead you straight away after a certain amount of iterations or repetitions to the base case. And when you reach the base case, you will exit your program. واضح? Okay. So this is just an introduction about how we can do it. Now, let me implement this. Okay. Let's see this in action. Is it clear? Small? Okay. Okay, so here I defined countdown as recursive and countdown as iterative, both of them. Okay, this uses a while loop and this one uses a for loop. Look now. So this is the recursion. I will count down number. If number is equal to 0, it will print countdown finished. Else, it will just call countdown again. Now, if I execute this one, 5, 4, 3, 2, 1, countdown, finish. Now, imagine that the base case, I remove it. I remove the base case. So look now. It will count down to many negative values and then it will just crash. Okay? It failed because we didn't put the base case. Now, if I put the base case, it will run safely. So recursion is very critical. Okay, you have to make sure that, now this is a very simple example, but in some cases you need to make sure that you will reach the base case. Okay, otherwise your program will be crashing. ما في for loop الآن. وين ما في for loop. This one I'm not using it right now. I'm using just countdown, and countdown is calling itself. So it's a method that calls itself. We have here a base case and a recursive case. Okay, so all you need to do to solve a recursion program is to find the base case and also the recursive case and put them together so that they converge to the solution. Okay, let me do another example now. So, all about the concept of computational thinking process that I always talk about. So now, in general, the things that you have done in CS101, they actually follow this process, which we call computational thinking process. So first of all, you need to decompose the problem, and break down the complex problem into smaller, more manageable parts. And this also applies to recursion, by the way. And then finding a pattern recognition. What does it mean, pattern recognition? Identify similarities or patterns in the problem to simplify the problem solving. We need to find a way, for example, equation. An equation is a pattern, okay? A relation between elements, it's another pattern. So you need to find on how to express this problem into some solutions, into some simple solutions. And this is what we call pattern recognition. Observe pattern and trends in the data. And then, if you have made your pattern, you're going to develop your algorithm, or what we call abstraction, which is like the English algorithm that I have shown to you, the steps, okay? And then the algorithm design, which is to develop a step-by-step instruction or rules to solve the problem. So usually when you have, for example, mathematical problems that you have difficulty to solve them when you have a matrix, or when you have to read from a file, most of the problems you jump directly into the code. In principle, this kind of problems you need to go, okay, this is a problem, how gonna solve it? You take a pen, take paper, and then try to decompose the problem. How I'm going to read the file? What's the structure of the file? What's the structure of the matrix? What's the relation between the file and the matrix? For example, you're gonna upload the text into the memory. So all of this you need to solve them in advance. And this is important, you need to do that many times until you get all the intuitions afterwards. Now, for the recursion, we're going to apply also a computational thinking process, and I will give you the following rules that you need to do for any recursion problem. Okay, this is the computational thinking process in recursion. First of all, understand the recursive problem. What's required? If you don't understand the problem, you cannot move forward. Now, when you read the problem, you don't understand it, that's the killing point. The most important thing, how can I solve the problem? Don't jump into the coding. It's useless. It's useless. First of all, understand the problem. What's required? What is the goal? For example, in our case, count down, or maybe we're going to do another one. Find the factorial of a number. You know that the factorial, for example, of 5, it's 2 multiplied by 3, by 4, by 5, and then by 6 for factorial 6, and so on. Okay, so I need to find what's the goal. Need to understand what I need to achieve. And then identify the recursive case. And also identify the base case. These are the two most important things. I'm going to start by saying the base case first, the stopping condition, and then the recursive case. Okay, the recursive case. Let me put it in red here so you always remember. These are the two main things to identify: the base case, the stopping condition, and the recursive case. And then you can also make a simple tree diagram showing the goal. I'm going to show you one example of tree diagrams, okay, showing the goal, how I should reach from the base case to from the recursive case to the base case. Then, after understanding the problem, you need to plan the recursive solution, and this is what we call the algorithm. You plan the algorithm. Okay, you can visualize the problem as nested operation. Nested operation, yani, it's a function that calls itself. Okay, or break down the problem into sub-problems. that resemble to the whole problem. Okay, and ensure that the solution is going always to move toward the base case. If it doesn't move to the base case, it means the problem will never end and it will crash. Okay, I will show you how to apply this concept. Now this is general. This is very general, and you will apply the concept on a particular example. Then, completed planning, now you go to the coding. Now it's the time to go to programming, either in Java or in Python, or we don't care about the language. The language is just a mean to solve the problem. But the most important thing is, let me first solve the problem. And then I'm going to try it. Okay, start with the base case in your function. This is what we have done in the Java. Then implement the recursive case. And then test, make testing to ensure that, for example, you test for one value, second value, okay, and make sure that it works as expected. And finally, you can evaluate more extensively. You can make multiple tests for the edge values, for example, from 0, or you try to consider extreme values, okay, to make sure that your program will not fail in any case. So here we make some initial testing, and here we will make some more advanced testing for evaluation. Okay, now if we want to apply this to our countdown, okay, now for example, the goal of this function is to perform a countdown from the specified number up to 0. Now this is the goal that I want to achieve. So the recursive case occurs when the number is not 0. This is the recursive case. Now I'm applying the general rule to the countdown example. This is an application. Okay, I'm going to repeat the same example by applying the computational thinking process. So we determine the base case, and the base case is n equal to 0. Then I plan the recursive solution. So visualizing the nested operation I will show in the next slide. Then implementation. So like we did in the previous code, we started by base case n equal to 0. Then we implemented the recursive case. Okay, we call the countdown n minus 1. And finally, we do testing. Okay, so this is the same. Okay, so this is the algorithm, and this is the same example. Just wanted to show you on how we can decompose. So these are the steps. These are the problem-solving steps to the solution that we're going to apply to any problem. Okay, so now this is a visual representation. You can imagine that you have like boxes. I'm going to make the countdown. So 5 is not 0, 4 is not 0, I'm going to remove it. 3 is not 0, I'm going to remove it. 2 is not 0, I'm going to remove it. Okay, so every time I call the same function. Now, I comes to 0, this is the stopping condition. I'm not going to move further. Okay. So this is the principle. Now, we're going to apply it to multiple types of problems. Some mathematical problem like factorial. Okay, factorial is also a basic problem to learn about recursion. So what is a factorial? Okay, usually we compute the factorial of a non-negative number. It means a positive number. Factorial of 0 is equal to what?
1.
And factorial of 1?
1.
Okay, so the factorial is just the multiplication of all numbers before the number that we're looking for the factorial. Okay, so this is the condition. N factorial is equal to n multiplied by n minus 1, multiplied by n minus 2, multiplied by 3, by 2, and by 1. This is the algorithm. Okay, so we have a constraint. It's important to now we are understanding the problem. We are in the first step, understanding the problem. We have constraint, the number must be non-negative. So any negative value, it must be excluded. If the user enters a negative value, I have to exit my program and say that there is an error. We cannot accept negative value. And the function must handle input within the range that can be represented by data types. You cannot calculate factorial of 1 million because the computer maybe is not able to reach a very huge value. You know that numbers are represented as, for example, int 16 or int 32 bits or 64 bits. Okay, this is what we can reach. So you have a maximum bound for the number. So we need to know which value will not exceed the allowed numbers into a certain computer machine, depending on the precision of that machine. Okay, so these are the requirements. The program should include the base case when n equal to 0. Okay, and this is a sample. If I take 5 output, so usually you start by making simple examples, 1 or 2 examples, and this will help you to identify the pattern. Imagine that I don't give you this equation. Okay, so you can say, okay, now this is an example of 5, this is an example of 1, and that's pretty much it now. Now, first of all, the first step is to understand the problem. I want to calculate the factorial of n, means multiplying a series of descending natural number from n to 1, and recognize that the factorial of 0 is equal to 1. These are the first two things that we need to understand. Now, if I understand this, I'm going to break down the problem. So, first of all, find the pattern. So the factorial can be expressed as n multiplied by n minus 1 factorial. So this is the key of the solution. If you are not able to identify this pattern, you cannot implement recursion. So what's the relation of this equation with the recursion? Because here factorial is calling another factorial. واضح? So I need to identify in recursion an expression where the function is calling itself. Now if I give you this example like here, it's not trivial. I'm giving just the bare equation. Is there anything that represents factorial here? Or represent recursion? No. There is no function that calls. But look, I can say now this is n, and look, if I take all this part here, this is n minus 1 factorial. So after understanding the problem, you must be able. Look, this is something that you don't do in programming. This is something that you do in hand. This is critical thinking, logical, computational thinking. Okay, mathematical thinking. Okay, so always don't jump into coding, especially with recursion. You need to find this kind of expression. How can I express the function f as, okay, calling itself by some of the means? So sometimes we don't give you the clear relationship. You need to do it mathematically. Okay, you need to find the pattern. Okay, so here the observation is that each factorial depends on the factorial of the previous number. So now n minus 1 will be equal, n minus 1 factorial is going to be equal to n minus 1 multiplied n minus 2 factorial, and so on. Okay, so this is the recursion relationship that I need to identify. Then I need to define the base case. Now this is the recursive case. This is the recursive case. And now I define the base case. What is the base case now? Identify the simplest possible input. What is the minimum input? It's non-negative number, so it's 0. If it is 0, value is equal to 1. Okay? This is the base case and stops the recursion. Look now, I am applying the same steps. So the steps, you need to go through them for every example. Okay. Define the base case and then define the recursive case. Okay, we've done the recursive case. For n greater than 0, we find the relation multiplying n by n minus 1 factorial. This we find in step 2. And then we combine both together. So I have the base case, I have the recursive case. How can I build my algorithm? Okay, so this is the algorithm. Starting point, I'm going to start by factorial of n. Then recursive base case, n equal to 0. Usually we start by the base case. N equal to 0 will stop the, okay, will stop the program. And n minus 1 will reduce the problem size, okay, to a descending step. So this is the recursive step. And the progress, each call with n minus 1 ensure the movement toward the base case. N minus 1, n minus 2, n minus 3. At the end, I'm going to come to 0. So I ensure that I will go to the base case. And now we implement the algorithm. Okay, look at the algorithm now. Calculate the factorial. What is my input? It's a number n. The output is the factorial of n. And now I will make a function, or in algorithm we call it procedure. Okay, factorial of n begins. If n equal to 0, this is the base case, return 1. Else, return n multiplied by factorial n minus 1. This is the pattern. This is the recursive case. Okay? To summarize, you need to find base case, recursive case. Okay? And sometimes it's not very clear from the problem. You need to make some understanding, problem elaboration. Okay? And finally, you will find this one. You get your algorithm one moment. Okay? Now, you have the main function, start. Set the number, for example, equal to 5. Okay? And the result will be factorial of 5. And finally display the number. Now I can translate this into any language. Yes, Ghazi?
Doctor, in the else statement, n times factorial n minus 1, the 1 shouldn't be a counter that increments?
No. Now n minus 1, factorial n minus 1 is going to call itself. Yes. So it will call this function, and this one is going to be n minus 1 factorial n minus 2.
Okay.
Doing that multiple times, it's like the mirror. Okay, always remember the case of the mirror. It's like calling itself, but it will stop at some point. It will stop when n minus 1, n minus 2, n minus 3, n minus 4 will come to a value equal to 0. Okay, if you stay 100, after 99 steps or 100 steps, it will come to 0. Okay, so it will stop. Huh? Else and the procedure, and the procedure stops here. Okay? Okay, now implement the function. That's another simpler implementation of the algorithm. And finally, we do that in Java. Okay, public static void main, factorial of number n equal to 5. And here, factorial of n. The base case, n equal to 0, return 1. And else, return n factorial n minus 1. And finally, we can do some testing. Look, test case 1, factorial of 0. We're going to test it. Okay, so this is a factorial tester. I will give you these functions. Okay, it will test the values for 0, for 1, for 3, for 5, for 7. Okay, for 0, for 1, for 3, for 5, for 7. And we'll make sure, so this is, you need to define what is the expected output and what is the output from the program. If the output from the program is equal to the expected output, now we have expected output, it means that everything is fine. Okay, so software testing is very important. For software engineering, you will have a complete course on how to do testing. Okay, unit testing and system testing, but this is a very simple example on how we can do testing on this example. And this is actually a tree representation. This is a tree representation of factorial. We start from factorial 5. Look how it happens. Factorial 5 is going to call factorial of 4. And factorial of 4 is going to call factorial of 3. And here you have the expression. And factorial of 3 will call factorial of 2. Factorial of 2 call factorial of 1 until we come to 1. This is the base case. Then it will roll up. Now 1. Okay. Now I have the expression of factorial of 1, so I can calculate factorial of 2. If I have the expression of factorial of 2, I am able to calculate the factorial of 3. Then I calculate the factorial of 4, then I calculate the factorial of 5. So it goes down, then goes up, because I need the value of every factorial. Okay, so from 1 I calculate of 2, from 2 I calculate that of 3, then that of 4, then until it comes to 5, so the final value will be calculated as such. So this is a tree representation of the factorial.